everyone. Hope you have understood all the videos and I hope that you are all safe at home. Okay. So today we are going to start a next concept, that is equipotential surface. Okay, what is meant by this equipotential surface? So once we know about the potential and electric field, we can imagine all the points in an electric field are at same potential. Okay, I'll give you an example. Consider the charge particle is at this position. Okay. So, we know that at a particular point, due to this point charge, at a point, the potential will be what? Q by 4 pi epsilon naught R. Okay. So, this is the potential. Suppose, if I take this position, what will be the potential? The same. Okay, same potential Q by 4 pi epsilon naught R. If I take this, here also it is Q by 4 pi epsilon naught R. If I take here, here. So whatever the points may be, the potential will be same, because potential at any point is equal to this one. Okay. So if I take, அதாவது இந்த distanceல நான் எடுத்தேன் அப்படின்னா, the potential will be, because it depends upon the distance, right? So the potential will be same for all these points. Okay. So இப்போ சென்டர்ல ஒரு சார்ஜ் இருக்கிறதா கன்சிடர் பண்ணிக்கோங்க. இந்த இடத்துல பாத்தீங்கன்னா இப்படி, இந்த இடத்துல பாத்தீங்கன்னா அதே சார்ஜ், இந்த இடத்துல பாத்தீங்கன்னா அதே பொட்டன்ஷியல். சோ இப்படி நம்ம எடுக்கும்போது அது ஒரு ஸ்பியர் மாதிரி இருக்கு இல்லையா, ஒரு பால் மாதிரி. சோ அந்த பாலோட அந்த சர்ஃபேஸ் ஃபுல்லா, ஒரு ஃபுட்பால் யூ கன்சிடர், அந்த சர்ஃபேஸ் ஃபுல்லா எந்த இடத்துல நீங்க பொட்டன்ஷியல் மெஷர் பண்ணினாலும் you will have the same potential. Okay, can you understand? So you will have the same potential at each point. Okay, or consider this is Q. Okay, so you will be having a surface like this. இந்த மாதிரி ஒரு surface இருக்கு, இந்த இடத்துல இந்த surface distance r என்கிற distanceல ஒரு surface இருக்கு. So when you measure the potential at this point, at this point, at this point, at this point, the potential will be equal. Okay, now consider another surface. Okay, when you measure the potential at this point, this point, this point, this point, all the potential of this surface is equal, but it is not equal to this surface. இந்த டிஸ்டன்ஸ்ல இருக்கிற அந்த பொட்டன்ஷியலுக்கு ஈக்குவலா இருக்காது. Since the distance varies, here the potential will vary, but at all these points it will have the same potential. Okay, இதுல எல்லா இடத்துலயும் பாத்தீங்கன்னா potential V1 will be here. When you take V2 will be here. When we take other one, here it will be V3. Likewise it will be going on. So for all the points they will be having a same potential. Okay, எல்லா இடத்துலயும் பாத்தீங்கன்னா potential it will be equal. Also we know that what will be the electric field for this point charge? It will be radially outward, right? Electric field will be radially outward. புரியுதா? Electric field இப்படிதான் இருக்கும், இதோட electric field இப்படிதான் இருக்கும். Okay, now can you understand what is meant by equipotential surface? I'll give the definition. An equipotential surface is a surface on which all the points are at same potential. இந்த surface, இந்த ஒரு surface எடுத்துட்டீங்க அப்படின்னா இதுல எல்லா பாயிண்ட்லயுமே potential பாத்தீங்கன்னா it will be same. Such a surface is called as equipotential surface. எல்லா surfaceம் அப்படி இருக்குமா? இருக்காது. So in some surfaces it occurs and such surfaces are called as equipotential surface. Okay, so I told you that the electric field is radially outward, right? So when you take the surface எடுத்துட்டீங்கன்னா இப்படி இருக்கு இல்லையா, இந்த இடத்துல this is the area. So when you take the surface, the electric field is always perpendicular to the surface. Keep this point in mind. The electric field is always perpendicular to the surface. For which surface? If it is the equipotential surface, the electric field will always be perpendicular to the surface. Okay, so the equipotential properties are very important. Okay, let us discuss. Two properties are given in your book. Let us discuss one by one. The first property is work done to move the charge from A to B in an equipotential surface is zero. This I have already explained you. If the potential is zero, okay, that means if the surface is an equipotential surface, the work done will be zero. Okay, so we know that we consider a charge is at position A. Okay, I have to move to this position B. Okay, or yes, I have to move to this position B. I am moving like this charge Q. Okay, so what I want to do, I have to do a work. Okay, நான் ஒரு work பண்ணி தான் இதை இங்க இருந்து எடுக்கிறேன். நம்ம வந்து prove பண்ணலாம் work done வந்து 0 அப்படிங்கறத let us try to prove it. Okay, suppose take this point. We know that what is equipotential, what is equipotential or potential energy. What is the potential energy? So we know that electrostatic potential. What is electrostatic potential? Electrostatic potential means potential energy per unit charge. That is called as electrostatic potential. Okay, so at this point we can write it as u1 into q1. Okay, you can write it as u1 into q1. Okay, similarly at this point you can write, sorry, yes, u equal to this one. Similarly here also we can write v is equal to u, the same charge, right? Say charge is same. So potential here, we know that at the equipotential surface the potential will also be equal, right? So this is also, or we can write u equal to v1 into q. Here also u equal to v1 into q. Okay, u equal to v1 q. Potential energy at a equal to v1 q. Potential energy at b equal to v1 q. Both are same. Okay, what is work done? Work done means what? இதுவும் இங்க இருந்து இங்க மூவ் பண்றீங்க இல்லையா, இந்த இதுல இருந்து இருக்குறது பிளஸ் இங்க நீ கொடுத்த எனர்ஜி ரெண்டும் சேர்ந்தாதான் உனக்கு இங்க கிடைக்கும் இல்லையா. Suppose for example I am taking this duster is in my hand. Now my energy is 100 joule. Okay, now I am lifting the duster. I have spent 20 joule of energy. 20 joule energy வந்து loss ஆயிடுச்சு. Okay, சரியா? Sorry, I having some 80 joules of energy. 20 joule of energy நான் கொடுத்து இத தூக்குறேன். இதுக்கு என்ன, இங்க இருக்கும்போது 80 இருக்கு, 20 கொடுத்து நான் இத லிஃப்ட் பண்றேன். லிஃப்ட் பண்ணும்போது இப்போ எனக்கு எவ்வளவு இருக்கு? 100. Okay, so at this point it is 100, at this point it is 80, this point 20. So I can write UA plus energy is equal to UB, or work done is equal to UB. So what is my work done? UB minus UA. புரியுதா? This is my work done. Just to consider this example. So what is UB? UB here I have got 100, right? What is UA? 80. So my work done is 20. Purida? I can easily calculate the work done. Similarly, we are going to calculate it. What is the work done? Here it is V1Q. Here also it is V1Q. So what is my total work done? It is a big 0. So we can prove that in an equipotential surface la irukra charge இந்த பாயிண்ட்ல இருந்து இந்த பாயிண்ட்க்கு அதே சர்ஃபேஸ்க்கு மூவ் பண்ணனும் அப்படினா நம்ம வர்க் கொடுக்க வேண்டிய அவசியம் இல்ல. புரியுதா? work done will be 0. This is the very first property and it is an important property. Always you keep it in mind. There is no work done when you move a charge from the equipotential surface from one point to another. equipotential surface லயே ஒரு பாயிண்ட்ல இருந்து இன்னொரு பாயிண்ட்க்கு நீங்க மூவ் பண்ணனும் அப்படினா work done 0. So this is the proof for that. It is not in the book. If you want you can take it out and whenever you are having doubt you can just refer it. Okay, then the next property is the electric field is normal to the equipotential surface. Already I told you, right? Electric field will always be normal to the surface. Okay, so if it is parallel, what happens? And the contradiction eduthu paapom. If it is parallel, what happens? This is a very important reasoning type question. They will ask you the question like this: if the electric field is parallel to the equipotential surface, is it possible? Why it is not? அப்படினு கேட்பாங்க. அது பாசிபிளா? அப்படி இருக்கலாமா? இது ஏன் அப்படி இருக்க கூடாது? Like that they will ask you the question. Okay, so if let us see, if it is normal, okay, the electric field is normal to the equipotential surface. If it is parallel, what happens? Let us see. We know that potential formula, that is equal to minus E dr. Okay, that means what? dW. Okay, dW equal to B is equal to minus E dr. That is dot product. So we can write it as E dr cos theta. Okay, so consider if it is normal. புரியுதா? அந்த சர்ஃபேஸ்க்கு நார்மலா இருந்துச்சுன்னா what about my theta? It is 90 degree. When you substitute it here, what about my value? V equal to 0. That means work done is 0. What is our first property? Work done in an equipotential surface will be 0. Okay, so this is right. In the property கேத்த மாதிரி இது work ஆகும். So it is right. If it is parallel, what happens? I have to substitute theta equal to 0. So if theta equal to 0, what about my V value or work done? Whether it will be 0? No, because cos 0 it is 1. So it will be having some value. So it will not be equal to 0. That means work done will not be equal to 0. this is not possible. It is a contradiction. நம்ம சொன்ன first property க்கு இது contradictா இருக்கு, எதிர்மறையா இருக்கு. அதனால it is not possible. Always the electric field is normal to the equipotential surface. Okay. Hope you have understand this topic, and you please understand the concept. This questions may be asked for a reasoning type question. A 3-mark question you can expect from this. Thank you for watching.